Lesson 4 and last lesson of the unit, uses and risks of nuclear power. We're going to talk about the beneficial uses and the harmful side effects of nuclear science. So first thing is the power plants. Nuclear reactors can generate electricity in a manner that does not produce CO2 and other greenhouse gases.
So one of the most common power points in the area is called Indian Point, which is in Buchanan, New York, which is roughly about 30-40 miles away from New York City. Indian Point actually powers a lot of the energy in the nearby areas, and because power plants don't produce CO2 gas, they do not create global warming. They're actually one of the main reasons why people want to go nuclear, is so that way the planet doesn't warm up anymore.
We're also going to use it for cancer therapy. Nuclear radiation can be focused in order to kill cancer cells in patients with certain forms of cancer. Radioprotective drugs are now available that can help shield non-cancerous cells from the high-energy gamma rays.
So we're going to use also technetium-99, and if you see a little M afterwards, it means it's for medical. So technetium-99M is used for locating brain tumors and damaged heart cells. This radioisotope is probably the most widely used radioisotope in medicine as of today. And another type is called iodine-131. Iodine naturally in your body is uptaked into your thyroid, which is right on your vocal cords, right above your larynx. So when you take up the iodine-131, either through injection or through eating, the iodine flows there, and you can use a Geiger counter or different types of scanning devices to indicate whether or not your thyroid glands is functioning properly.
Food irradiation is a method of treating food in order to make it safer to eat and have a longer shelf life. This process is not very different from other treatments such as pesticide application, canning, freezing, and drying. The end result is that the growth of disease-causing microorganisms, or those that cause spoilage, are slowed or eliminated altogether. This makes food safer and also keeps it fresh longer. This does not make the food radioactive, just allows us to transport it to places in farther locations.
We also use radioisotopes in geological dating. So for example, uranium-238, we can use that to figure out how old rocks are. We can determine the ratio between uranium-238 and lead-206, and that tells us the age of the Earth. And the other type of dating that we do is carbon-14, because there's an isotope of carbon called carbon-14, and as all living things accumulate carbon, which is gaining in mass and body size, cell replication and whatnot, when your organism dies, plant or animal or bacteria, it has a very specific ratio by mass of carbon-14 to the standard carbon-12. This is going to be the same ratio as what we find in the atmosphere at that time. So at the moment of death, when the body is no longer intaking carbon, therefore we can then determine how old it is based on the ratio of carbon-14 to carbon-12.
Remember back in half-lives, once something is radioactive, it will forever and always be radioactive. So no matter if it's carbon or uranium or lead or iodine or technetium, it's always going to stay in that being. So that's something that we can always test for.
In smoke detectors, for example, like the ones in the classroom and the ones at hopefully your apartment or house, they use a very specific type of radioisotope, which is called americium-241. This radioisotope emits alpha particles, which are then directed at a metal plate. If there is some sort of blockage to that metal plate, in the example of a fire where the smoke particles will neutralize the positive charge, that will then stop the circuit, which then triggers that very loud and annoying alarm.
Not all smoke detectors are radioactive. They actually have to state it on the package when you buy it. So the dangers of nuclear power, they damage tissue cells, they can cause gene mutations, they cause radioactive waste that has very long half-lives, and then there's also nuclear accidents that can occur, like Chernobyl.
Yeah, and did you also know that we dropped nuclear bombs, I think in Virginia, on ourselves, and no American really knew about it because it wasn't publicized? They dropped atomic bombs into like a farm, and they didn't explode, but they were just hidden underground for like 10, 15 years until they refound them.
Oh,
yeah.
Fun fact.
Yeah, terrifying.
У нее нет ни запаха, ни цвета. У нее есть только голос. Вот он.
April 26, 1986, the Ukraine. is seen in this Russian documentary. Reactor number 4 at Chernobyl explodes and burns, pouring radioactive material into the atmosphere. 31 people die on the spot. Children were found to be most vulnerable. In the days after the explosion, a cloud of radioactivity that started out 200 times stronger than the Hiroshima and Nagasaki bombs spread across Russia and Europe. Back at the site, firefighters facing certain death with superhuman courage put out the blaze and poured thousands of yards of concrete on the damaged building, trying to entomb it forever. Filmmaker Vladimir Shevchenko, who shot this incredible footage, was among those who died of radiation poisoning. As bad as Chernobyl was, it could have been much worse. If the wind had been blowing the other way, Chernobyl might have devastated the city of Kiev 80 miles to the south. Kiev's population is 3.25 million. The explosions at Chernobyl occurred while an experiment was being run in the reactor. Incredibly, the experiment was conducted with the emergency water cooling system shut off. When the experiment went bad through a series of mistakes and miscalculations, a runaway reaction began. Out of control, the reaction shattered the fuel and eventually blew the roof off the building, exposing the core to the atmosphere.
Chernobyl was the design disaster. I mean, first of all, the Soviets had much weaker and less safe designs for their nuclear power plants than even the U.S. Manufacturers of nuclear power plants. And coupled with a whole culture of secrecy, cover-up, bureaucratic flank covering, it was a recipe for disaster, and it occurred.
Nuclear power plants in the United States and Europe are designed and maintained to much higher standards than the ones at Chernobyl. But even so, could such an accident happen here?
The NRC, back about 15 years ago, thought that in the next 20 years it'd be one meltdown all the way. It hasn't happened yet. When it happens, it'll happen, without any alert.
Yucca Mountain is a range of mountains in Nevada. It is a large, long-term storage facility for nuclear waste and testing. The reason why, if you think about Nevada, very little rain, very little earthquake issues, hurricane, tornadoes, all those are very, very, very infrequently found.
No one also lives in the middle of a desert,
right,
so it's kind of far away from people or animals.
Right, so it causes this to be an ideal location to store any nuclear radioactive waste.
And if you've seen the last Godzilla movie, this is the scene where the aliens actually hatch out of the mountain and then go towards Las Vegas. That mountain is where they keep all radioactive waste.
Fun fact, the United States will not reuse the radioactive waste to do more nuclear power plant. However, France runs 80% of their country on nuclear power because they reuse their waste.
Viva la France.
You went about 2,000 feet here. And we'll get on this other cart here. Everybody in. So basically what you're seeing there is salt. That's rock. You can hit that with a hammer and it'll ring like a bell. We're going to go through an airlock here. And these airlocks, the reason we have them is we have 4 different ventilation splits. And then all those areas are kept separate. Some of it is to control the possibility of, if you had a release of some sort, of controlling that ventilation and that release. And some of it is just literally to be able to control the air because you've got a finite amount of air. So the waste would turn here. This isn't going into an active panel. We're headed into the panel where the waste is disposed. This is the panel itself, but this is typical of these rooms. They're 33 feet wide, minimal 13 feet high. In the case of a room, it's 300 feet long. So the RH waste is brought down in this room, and then these pistons, the rams, push it into the hole. And there's interlocks and there's shielding associated with that to protect the workers. They leave the shield in place and they come in and they pull the piston back and they put that shield plug in place and then they push that in also. So here's the CH waste stack.
There's your contact handled waste.
Basically, we want to emplace this. It's not storage, it's disposal.
It's permanent disposal.
I guess you could always think that the folks in the future could be smarter than us and find some use.